In this chapter, the applications are tremendous, wide variety. I would like to focus on two: exponential growth and exponential decay. Of course, the logistic function will be there, but there are not too many examples in your book about logistic. More in the other, in 141. Okay, so the exponential growth, what grows exponentially? Bacteria grows exponentially. Rats or populations grow exponentially. Rats, rabbits, even people, they grow exponentially. The exponential decay. What is the exponential decay? Normally deals with mass of radioactive substance. And the radioactive substances, they decrease their mass in time. And the two models that we are going to use, they will be given to you. You don't have to memorize them, but they are all the same. So n of t, which is number, n, function of time, equals n0, the initial number, times e to kt. K is the exponential growth rate, t, minutes, hours, years, whatever. The exponential decay deals with mass, so that's why we have m of t, and this is m0 e to negative kt. I'm sure you see how similar they are. Of course, one will be increasing on all its domain, and the other one will be decreasing in all its domain, but they are otherwise the same. Initial number of people, rats, bacteria, initial mass of radioactive substance, K is the growth rate, and T is time. Okay, let's start with problem 14 on page 351. We will be given the model, and we just want to practice and do and answer the questions based on the model. Bacteria culture is entitled. The count in a culture of bacteria was 400, count 400, after 2 hours, and 25,600 after 6 hours. Before I even read the problem, I'm going to ask you, and ask myself if you want, what is given here? What am I given? What are these?
You give your numbers and your time.
Right? But normally when I have two variables, what am I really given?
Ratio.
A point, right? Right? So when I'm given time and the count, these must be two ordered pairs, 2 points, right? And what is the independent variable? That is very important. So how do I write the point? This is extremely important. Of course, right. Time is the independent always, and the bacteria count is the dependent variable. Very good. Now I can read the first question. What is the relative rate of growth of the bacteria population? Express your answer as a percentage. So in part A, what am I really asked to determine? Of course, this is the model, because we're talking about bacteria. So I know the model will be n of t equals n0 times e to kt. What am I asked to determine from all this? Yes, K is the question. Thank you. Indeed. So in part A, I'm asked to find K. Good. So what should I do? Any suggestions? Exactly. I'm ready. I have to plug in the first point, and then I have to plug in the second point. So can anyone dictate? For the first point, what do I write?
400
Correct?
equals n to 0.
Yes, n0, which is unknown, the initial number.
E k times 2.
Very good. Excellent. Okay, very good. This is what I have from the first point. Perfect. Can anyone dictate for the second point?
25,600 equals n to 0 times e to 6k.
Perfect. I have two equations, and I'm trying to solve for k. I have several options here. Can anyone suggest any option? 'Cause I'm really interested in this. This is my question here. What should I do? Because I also have this variable.
Would you put e to the 2k, e to the 6k on the same side so that you can get one of the variables by themselves? Would you solve that variable and then come back to k?
But see, this is not identical variable.
Okay.
But this is, you're on the right track, but this is an identical variable. I could, but I have two variables and a system of equations and two variables. Well, I have two options. One is substitution, and the second option is to divide both sides, divide both equations. The first one is the easiest to see, I think. I will solve the first equation for n0. Can anyone give us n0 from the first equation?
n0 equals 400 over e to k.
2k. Good. So I'm going to replace it in the second equation. So I have 25,600 equals 400 over e to 2k times e to 6k. Now, I would like to simplify this. They have the same base. I will copy the base. And what happens with the exponents? When I divide, I copy the base, subtract. From 6k, I have to subtract 2k, and I get good. So I'm on the right track. Dividing both equations, the left-hand side and the right-hand side would have given us the same thing, because I would have simplified n0. It would have been the same thing. Okay, so then now how do I clean it up? It's not ready. Yes, I'm going to have to divide both sides by 400, so 256 over 4 equals e to 4k. And 256 is what? Is it 64? 25 divided by 4 is 6. 64. Okay. So I have that 64 equals e to 4k. And how do I proceed? I apply natural log to both sides. I get 4k. And finally, very good. So k equals natural log 64 divided by 4. So if you have the number, natural log 64, everything divided by 4, I got a 1.0397. And in percent, how much will this be? Very good. Approximately 104%. Okay, so what do I know about the model? I know that n of t equals n0 times e to 1.0397 t. This is what I have so far. After answering part A of this equation, I have this. Okay. Part B, what was the initial size of the culture? So what am I asked now? Yes. So now I'm asked to find n0. But I have an equation for n0. It's right here. It's this one. n0 equals 400 over e to 2k. So n0 equals 400 over e to 2 multiplied by 1.0397. To get the best approximation, just put 400 and divide that by e, in parentheses, 2 multiplied by the previous answer, and close the parenthesis. So I got 50. So what is the initial size of the bacteria population? Or bacteria count, I should say. 50. 50. Count 50. Good. Initial count. Find the function that models the number of bacteria, n of t, after t hours. That's part C. I already have it. Can anyone dictate the equation? N of t equals 50, 1.0397 t. Very good. Thank you very much. Very good. Part D. Find the number of bacteria after 4.5 hours. What should I do? Plug it in. So I have 50 multiplied by E, in parentheses, 1.0397 multiplied by 4.5. And I got 5381. So the number of bacteria grows to 5381 in 4.5 hours. Finally, when will the number of bacteria be 50,000? When will the number of bacteria be 50,000? What should I do in this case? 50,000 equals?
50 times e to 1.097.
Perfect. I need to clean it up first. What should I do? Good. So when I divide by 50, I have 1,000 equals e to 1.0397 t. Since 1,000 and e can never be presented with the same base, apply natural log. Very good. So natural log of 1,000 equals 1.0397 t. Therefore, t equals natural log of 1,000 divided by 1.0397. So natural log of 1,000 divided by 1.0397. I got 6.6 hours roughly. Is that correct? Are we okay? Did I plug in something? Okay. Any questions? I would like to look at radioactive decay. Before we pick a problem on radioactive decay, I would like to mention one thing. Radioactive substances have what it's called a half-life. What is a half-life? Assuming we have 100 milligrams of a radioactive substance, let's say whatever it is, X. And let's suppose that half-life is 50 years. We normally denote it by H. So 50 years from now, how much should be left from 100 milligrams? We start with 100 milligrams of a radioactive substance that has a half-life of 50 years. In 50 years from now, we will still have how much? 50 milligrams. In the next 50 years, how much will we have? And so on and so forth, right? In the next 50 years, we'll have 12.5, and so on and so forth. Good. So I'd like to look at problem 20 on page 352. Radioactive radium. Radium-221 has a half-life of 30 seconds. How long will it take for 95% of a sample to decay? Okay, the formula will be given to you. Or the model, which is m of t equals m0 e to negative kt. We do have an initial quantity, which is unknown, initial mass of this radioactive substance. We are told that the half-life is 30 seconds. This is our starting point. So what is that point, if you want, I should say, ordered pair? That's where we should start. What is the ordered pair that is given here indirectly? It's hidden, but it is given. Knowing that we start with m0. What would be this ordered pair? Comma m0 over 2. Very good. 30 m0 divided by 2. So if we start with m0, in 30 seconds we will end up with m0 over 2. This is the point or the ordered pair that I have to use in the problem. Please tell me how to use this point in the model.
Do m of 30.
Yes, this will be m of 30, but from here I know that m of 30 equals
M of 0 times e.
So if this is x, this is f of x.
Okay.
If this is 30, this must be f of 30,
Okay.
right? So m of 30 has to equal m0 over 2. Because in 30 seconds, the mass remaining is the initial divided by 2. So now please tell me how to write the model. It's no different from here. You told me with 2 comma 400, right? You said 400 and you put 2 in t. It's exactly the same.
It would be m of 30 equals m0 over 2 e to the negative k times 30.
So this is my m0 over 2 when t is 30. You could write it as m of 30, which is m0 over 2, which also equals m0 e to negative k times 30. But I don't like to have two equal symbols in an equation, so that's why I would like to drop this part. Does this make sense? So in 30 seconds, the mass, the initial mass, decays to half. So in 30 seconds, we only have half of it. We know that we had initially m0. We don't know exactly what it is, but I still know that in 30 seconds, I get m0 over 2. So when t is 30, the mass is m0 over 2. Is this clear? Yes? So when t is 30, this is m0 over 2, and this is also 30. So I have m0 over 2 equals m0 e to negative k times 30, or negative 30k. Of course, I have two variables, and I'm hoping that I can get rid of one of them very easily. How do I get rid of, and which one? So another way of writing the left-hand side is 0.5 m0 equals m0 e to negative 30k. And now it's easier to see. I will divide both sides by m0. So then 0.5 equals e to negative 30k. So I clean it up, and I can apply natural log now. Natural log. So I have natural log 0.5 equals negative 30k. Therefore, I know k must equal natural log 0.5 divided by negative 30. So when I put this in the calculator, I have natural log 0.5, and I divide by negative 30. I got that k is 0.0231. Now, we only have k, right? So let's go back and put it in. So now I have m of t equals m0 e to negative 0.0231 t. I'm asked now to find the time needed for 95% of the sample to decay, to go away. So when I'm asked to find the time such that 95% of the sample decays, what do they mean by that? What does this equal to? So 5% because 95% is gone. Very good. So what is the operation? No, I cannot. I cannot. So see, very good question actually. What did we do here? We wrote 50% of m0, right? Because half-life means 50%. So 0.5 of m0. Now, if 95% is gone, what is left? Yes, 0.05 of, which means multiplication of m0 equals m0 times e to negative 0.0231 t. Very good. And what should I do next then? Because 95 is gone, 5 is left. 5% of the initial that we don't have. Yes. So I have 0.05 equals e to negative 0.231 t. And now this is ready for so then t equals natural log 0.05 negative 0.0231. I got 30 because I made an error. It's not possible. No, I just I forgot to put a 0 in there. I used the previous measure of 0.05 and divided by okay. I got roughly 130. Is that correct? Okay, so T approximately 130 seconds. So in 30 seconds, 50% of it is gone. In 130 seconds, 95% of it is gone. It decayed. Okay, I think we should look at another problem, and then we can move on. So there are so many different applications, as I said. The next, and I'm not going to ask you to do that, but we can choose a problem. You don't have to memorize any formulas here. Cooling soup, 25. I'll let you decide. Finding pH. Ion concentration in wine. Earthquake magnitudes. Subway noise, traffic noise. Inverse square law of sound. Everything is all natural and log, exponentials and log equations, expressions and functions. So would you like to look at another radioactive? Or you would like to look at cooling soup? Another radioactive or cooling soup?
Soup.
Okay, very good. So 25 on page 352. A hot bowl of soup is served at a dinner party. It starts to cool according to Newton's law of cooling. So its temperature at time t is given by uppercase T, temperature of time t, equals 65 plus 145 times e to negative 0.05 t, where t is measured in minutes and t is, uppercase T is measured in degrees Fahrenheit, and t in minutes. Okay. What is the initial temperature of the soup? Here is the Newton's law of cooling. If D0 is the initial temperature difference between an object and its surroundings, and this is D0, and if its surroundings have temperature Ts, temperature of the surroundings, then the temperature of the object at time t is modeled by the function, where k is the positive constant that depends on the type of object. Good. So what do I'm asked to find? I'm asked to find the temperature initially. So what do I always do, no matter what function I have, for initial temperature?
Times 0.
Very good. So let's do this together. Negative 0.05 times 0 is
0.
e to 0, 1. 1 times 145, 145. 145 plus 65, 210. Very good. Part B. What is the temperature after 10 minutes? I will plug it in. So 65 plus 145 times E, 2 in parentheses, negative 0.05, 0.05, and multiplied by 10. I got roughly 153, or if you want 152.95. Is that correct? Okay, part C. Let's see, where am I? After how long will the temperature be 100 degrees Fahrenheit? What am I asked to do now?
replace your temperature with.
Very good. So this is 65 plus 145 times E negative 0.05 T. What would you tell me to do first?
Subtract 65.
Good.
So that's
So I get 35 equals 145 times E to negative 0.05 T. Then,
so I know
good, 35 over 145 E to negative 0.05 T. Don't bother with that fraction. There's no need. And now, so then we apply natural log and we divide both sides by negative 0.05. So natural log, in parentheses 35 over 145, and divide by, in parentheses, negative 0.05. So roughly 28.4. And the time was given in minutes, correct? This is what I wrote. Very good. This is the end of chapter 4. Now let's see what we can accomplish from chapter 11. In chapter 11, we have to look at 4 different things. Number 1, circle. Number 2, parabola. You can say parabola, we discussed that before. Yes, but we are mainly concerned now in this type of parabola, which is not a function. Not the parabola that we know and it's a function. I'm more concerned about that than the other one. They have some similarities, however. Ellipse and hyperbola. Okay, let's start with the circle. The circle is in chapter 1, so this is 1.8. This is chapter 11. So we start with the circle. Assuming this is a circle, and this is its center, and this is the radius, lowercase r. Normally we denote the center of the circle by C, and the x and y coordinates are denoted by h and k. So I have a point on the circle whose coordinates verify the equation of the circle, which we don't have yet. We will in a minute. And we have the center, which is denoted by h comma k. Does anyone remember the distance formula? Because this is a distance between A and C. What is the distance? What does it equal to? Well, the distance AC is the same with the radius. So can anyone remind us the distance formula?
I'm missing something. It's x minus h over y minus k.
That is the that
X plus
minus.
x minus h squared.
So x minus h, everything squared, plus
Y minus k squared.
everything squared equals the radius. Excellent. So let me give you the distance formula one more time. So distance between A and B is written normally as x2 minus x1 everything squared plus y2 minus y1 everything squared. Where does this come from? If you remember from the right triangle, this is A, this is B. This is y2 minus y1, and this is x2 minus x1. And this is the distance. This is x1, y1, x2, y2. So the distance squared will be x2 minus x1 squared plus y2 minus y1 squared, and we take the square root from both sides. So now we are applying the same formula here, where the first point is C and the second point is A. So x2 minus x1 squared plus y2 minus y1 squared with the square root equals the radius. Now I will square both sides, and that is the equation of a circle. Equation of a circle. X minus h, everything squared, plus y minus k, everything squared, equals r squared. This is the equation of a circle. So we are in section 1.8 just for a minute to look at this circle. And what I would like to look at is, let's say, problem 104 on page 94. Show that the equation represents a circle and find the center and the radius. And I will add also graph it. So we are given x squared plus y squared plus 6y plus 2 equals 0. Well, I don't know whether this is the equation of a circle or not, but if I manage to present it like this, if I do something to this equation and I show that it's similar to this, then I know it's a circle. But I have to be able to identify a positive number as being its radius, not 0, and I should be able to identify the coordinates of the center. So, any suggestions? Is there any method from the past 3 months that rings a bell and has to be applied here? Any suggestions? There is a method that I said a long time ago, this is not useful. Now, at that time, it wasn't useful. I said, no, we are using it, or we need to know it for something else later.
It wasn't completely square.
Exactly. It's completing the square. So x squared is alone. It does not have an x term or term with x alone. But y squared and 6y have to form a perfect square. This is already done. Can anyone identify h? 0, of course. But we have to be able to identify k, but in this form I cannot. So what is the procedure? We have to identify the middle coefficient, which is 6. We have to divide it by 2, which is 3. We have to square 3, and we get 9. And this is the number that we have to mandatory add to both sides. So now the equation becomes x squared plus y squared plus 6y plus 9. I will move 2 to the other side. I'm subtracting 2 from both sides. Good. So the first is already completed. This is square. But what about this? What is y squared plus 6y plus 9 equal to?
That's 3 squared.
That's it. So now we are able to identify the radius and the coordinates of the center. What is the radius? That's fine. -3. Because we have to compare +3 with -k. So when I said +3 equal to -k, then k is -3. And what about the radius? No, this is the square. Square root of 7. Assuming the square root of 7 is 2.5, so I can graph. I would like to graph this. So here's how I graph it. 0, -3 is right here. So that I start with the center. So let's say the square root of 7 is roughly 2.5. 1, 2.5 to the right. 1, 2.5 up. 1, 2.5 to the left, and 2.5 down. So I've created 4 points, north, south, east, west, and now I can graph the circle. So the equation of this is x squared plus y plus 3 squared equals 7. This point here is c of 0. Oh! It's 0, -3, and I graphed it at the positive side.
I saw that, and it didn't really matter that much.
So what I'm going to do is I'm going to put the x-axis here. Okay?
And when you were creating your dots, you pretty much just took the square, drew down the square.
Yeah, because it was difficult to plot to, yeah, I said roughly 2.5. It's not, right? Sorry about that. Daydreaming. Now, if I ask you what is the domain and range for this circle, what would you say? Assuming that the square root of 7 is 2.5. It's not. But what will be the domain and what will be the range?
-2.5 to 2.5.
So the domain will be yes. And what about the range? If this is -3 and I go down, further down to -5.5 and up to -0.5, right? -5.5. Good. That's the idea of the circle. Let's go back to chapter 11. Okay. I would like to show you when we look at the parabola. Yes, there are two situations. This is one. This is the other. And also, this is what the focus of the chapter is all about, really. Parabolas that are not functions. Parabolas that have a horizontal axis. Horizontal. These have a vertical axis, which we know how to graph and so on and so forth. I like to focus on this. Before we look at those graphs and determine a few things, I'd like to show you, this is a very important application in optical or optics and also physics. So the geometric definition of a parabola. Yes, they present the geometric definition on a regular parabola that is a function. And then they have here details about that. This is what I'm really interested in parabolas that we don't really know how to graph, because we haven't learned that yet. So this is what I'm interested in. But I like to show you the definition here. You can see it. Here it is. A parabola is the set of points in the plane that are equidistant. Equidistant means at the same distance from a fixed point F called the focus. So this is the point F. Here's the focus, F. So, and the fixed line, L, called the directrix. So this is the line, and any point on the graph of the parabola is at the same distance from the focus and from the directrix. Any point. This point has the same distance from the focus and the same distance from the directrix. So this equals this. Any point, anywhere you want. This will equal this. This is the geometric definition of a parabola. Now, all I would like us to be able to do is see the difference between the two. Yes, I can show you how the following two expressions come into play. 4py, and the other one, y squared equals 4px, sorry, 4px. How do you think we come up with this one? Okay, allow me to go graph so I can explain what I'm doing. In this chapter, we will only look at parabolas that have the vertex at the origin, which is not always the case, of course. So here's the parabola. Here is the focus. The coordinates of the focus are 0, p. This is p. The distance between the focus and the x-axis or the vertex. This is the line that is called directrix. And this distance is also p. So this point, any point you want to pick on the parabola, will be found at the same distance from the focus and from the directrix. Now, can anyone give us, let's say this is point P, x, comma, y. Can anyone express this distance for point P? What does it equal to? This piece plus this piece. And by the way, this is y equals p, the equation y equals p of the directrix. So can anyone tell us the distance between p and the directrix? What does it equal to? What is this piece? From the x-axis till point P. What does it equal to? The coordinates of the point are x, comma, y. So this is y, and then minus p if you want, because you know that p will be a negative number, right? So the distance between here and here will be y plus p. I understand what you're saying, because y plus, so p could be a negative number. So yes, this is the x-axis. This is the directrix. Yeah. Okay, and now this must equal by construction, by the definition of the parabola, with this distance. Can anyone give us the equation of this distance, or the distance? It's the square root of x minus 0 plus y minus b. Everything squared. Okay, so after you square both sides and you get y plus b squared equals x squared plus y. So p will be a negative number, y plus. No, it is minus. That's true. So y squared minus 2py plus p squared. You don't have to memorize any of this. I just want to show you how we get that. That's all. So this is y squared plus 2py plus p squared equals x squared plus y squared minus 2py plus p squared. From here, y squared and p squared will go away, and that's how we get x squared equals 4py. So by setting this distance equal to this distance, we determine the equation of the parabola. And if we have x squared equals 4py, or if we have x squared, that's what I really want to identify. If we have x squared and y is power 1, we are looking at this or this. If we are looking at y squared equals 4px, it will be either opening to the right or opening to the left, because this is not a function. Not a function. When you take the square root from both sides, you have plus or minus. So these are, in here, there are two functions. This is one function. That's why this is the regular parabola we know. This is not the regular parabola. It opens either to the right or to the left. Okay, so all I would like us to do is just to be able to identify. So that's the first thing that I would like us to know, to just discuss, just this little thing. I have between 11 and 22 on page 730. I would like you to choose a parabola that is not a function, so we can discuss. And we will be able to find the focal diameter. I'll explain what it is, the directrix, the focus, and sketch the graph. So between 11 and 22 on page 730, I would like you to choose a parabola that is not a function, so we can graph it and find the rest.
21.
Number 21, perfect. 21 on page 730. So we have 5x plus 3y squared equals 0. I will have to present it like this. What will you tell me to do? Very good. So we have 3y squared equals negative 5x. So y squared equals negative 5/3 x. Okay. Now we will compare. So y squared equals negative 5/3 x with y squared equals 4px. We're asked in this problem to find a few things. We're asked to find the focus. We're asked to find the directrix. We're asked to find the focal diameter. And we're asked to graph it. Very good. So I have y squared, which is y squared, by comparison. I have x, which is x. Then I have an equation. Can anyone dictate that equation that I'm referring to? These are the same, these are the same. Therefore, these two must be the same. So what equation should I?
Negative 5 thirds equals 4.
Very good. So now I have P as being negative 5 divided by 12. Good. When P is a number less than 0, the parabola will open to the left. Good. So I know that the parabola passes through the origin. I know that, what is negative 5 divided by 12? Whatever it is, I'm going to graph it here. So I'm going to say that this is 5 divided by 12, and x equals 5 divided by 12 is the directrix. It's x equals negative p. So from the list, I determine I'm sorry, I swallowed a C, directrix. Good, so we have that. The directrix is x equals negative p. Now the focal diameter is, I want to show you a graph because I like these graphs here. If there is one, yes, there is one. So this is a parabola that opens to the right, which means P is positive. So x equals negative P is the directrix. The vertical line parallel to the directrix going through the focus is called the focal diameter, or also latus rectum. So this is the length of the focal diameter. The vertical line passing through the focus parallel to the directrix. And this length is 4p with absolute value. Somewhere here is written, okay. So the focal diameter is the absolute value of 4p. So I have p. P is negative 5 over 12. So I can erase this from my list or check this from my list. So the focal diameter is the absolute value of 4p, which is the absolute value of 4 multiplied by negative 5 over 12, which is negative 5 over 3. So this is the absolute value of negative 5 over 3, which is 5 thirds. So that's the length of the focal diameter. Now about the focus. The focus is 0, p. Again, it's difficult for me to plot something like this, so you have to trust me. I'm going to just try to make it as equal as possible. So this piece must equal this piece. So I'm going to say that this is the focal focus. Now, the length, again, the numbers are so difficult to show you much here, but I'm going to. So when I graph the parabola opening to the left, the length of the focal diameter has to be 5 thirds. It's not going to be 5 thirds because, of course, this is not 5 over 12. But I'm going to find other points to make it, in order to be able to graph the parabola, I have to find another point. So I will say what happens when x is negative 3. When x is negative 3, I will simplify and I'll have 5. The square root of 5, so x squared equals 5, 2 point something. So when x is -3, okay, this was this all happened because the numbers are awful. So I'm going to say this is 1 to -3. At -3, 1, 2, 1, 2. When x is -3, I have y squared equals +5. And when I take the square root, I get this point positive and this point negative. So now I can graph. This, which of course is not true because the dimensions here are terrible. This, the distance between this and this is 5/3. And this is the focal diameter. Focal diameter. The vertical line parallel to the directrix going through the focus. And its length is this. So we have the focus and we have graphed it. We have the focal diameter and we have the directrix. Maybe we should choose one more so I can, hopefully we have, let me choose. Because I like to show with nicer numbers, like yeah, let's look at 13. So 13, y squared equals 4x. We have the same 4 questions here. The focus, directrix, focal diameter, and graph it. Good. So we are comparing to y squared equals 4px. There is an equation here that I have to solve because I need to find p. So what will you tell me to write? Anyone?
P equals 4.
Good. So then p equals 1. When p is a positive number, the parabola will open to which side? Very good. So then this line is the directrix, x equals -p, or in this case, -1. The parabola will go through the origin. Can anyone give us the coordinates of the focus? Yes. I didn't write it here correctly. So p comma 0. And this is, what was p? 5 over p. Okay, so this is f of -5 over 12 comma 0. Very good. Can anyone give us the focal diameter? And now this will be so much easier to graph. What is the focal diameter? The absolute value of 4p. But since p is 1, 4. And there is no problem now. I know this is the next point, the point I need, and this is the other point I need. 2 up, 2 down. And this is done. So we have the focal diameter, which is 4. We graphed it. We have the directrix, which is x equals -1. And we have the focus, 1 comma 0. That's all I need for this. The ellipse. x squared over a squared plus y squared over b squared equals 1. This is the equation of the ellipse. How does it look like? An ellipse can look like this. We're talking about the ones with the center on the x-axis, the origin. So an ellipse can look like this if this number is greater than this number. So if a is greater than b, it looks like this. Or it looks like this. In other words, it has the major axis. We call this the major axis on the x-axis, or the major axis on the y-axis when b is greater than a. Okay. On page 739, let's say problem 12. We have 4x squared plus 25y squared equals 100. The question is this an ellipse? I don't know. The equation of an ellipse has to look like this. Therefore, what would you recommend we do first? I have to divide by 100. Very good. So I divide by 100, both sides. 4x squared over 100 plus 25y squared over 100 equals 1. How do I simplify 4 with 100? So the new equation is x squared over 25 plus y squared over 4 equals 1. Since this is a squared and this is b squared, can anyone tell us whether this ellipse will have the major axis on the x-axis or the major axis on the y-axis? X-axis. How much is a? Good. How much is b? Good. So let's graph this. One, two, three, four, 5 on the positive side of the x-axis. 1, 2, 3, 4, 5 on the negative side of the x-axis. Up 2 on the y-axis and down 2 on the y-axis. And now we're trying to connect. These are called vertices. Let's identify the vertices. This one. Negative 5, 0, and 5, 0. And of course, 0, 2, and 0, negative 2. If we're asked to determine the major axis, what will you say? What is the length of the major axis?
10.
Exactly. Minor axis, what is it? 4. Very good. We're also asked to determine the foci. The ellipse has 2 points and I would like to show you. I like the graphs that they present in this section, in this, okay. And also about the construction of an ellipse. I really like that. I like the way they present it here. This is very, very nicely presented. Geometric definition of an ellipse. An ellipse is the set of all points in the plane, the sum of whose distances from two fixed points F1 and F2 is a constant. Those two fixed points are the foci, plural of focus, of the ellipse. So here's how the ellipse is constructed. They put two pins here, and they taken whatever length of thread that you want, and they go around those two foci. It depends on what you want. You can even graph a circle, actually, if the two become one. So F1, the first focus, negative c comma 0. The second focus, c comma 0. How do we determine the c? And they show here a lot of work. How do we determine the c? Once we have the c, then we have the foci, the position of each of those two. Well, the formula to find the c is c squared equals a squared minus b squared. I already have a, which is 5. I have b, which is 2. So then c will be 25 minus 4. C squared will be 25 minus 4. So c squared will be 21. So c equals plus or minus the square root of 21. So square root of 21 is a little bit more than 4, but less than 5. So here will be F1, and here will be F2. The coordinates of F1 will be negative the square root of 21, 0. The coordinates of F2, the square root of 21, 0. Is there anything else they wanted us to determine here? Oh yeah, in the eccentricity. Okay. So the question was asking us, let me write down what it was. They were asking us vertices, foci, and eccentricity of the ellipse. Determine the length of the major and minor axis, we did, and sketch the graph, we did. So the only last thing is the eccentricity, which is E C divided by A. So the eccentricity is C in our case, 21, the square root of 21 divided by A, which is 5. I need to determine this number, and I'll explain in a moment what it means. It's deviation from a circle, actually. So the square root of 21, and I divide this by 5. So 0.9165, approximately 0.9165. The eccentricity of every ellipse satisfies, it must be between 0 and 1. If I like this graph, these graphs very much too. So if the eccentricity is close to 0, the ellipse is almost a circle. The higher the eccentricity, the further away from a circle the ellipse is. This is a high eccentricity. As you see, this is far from being a circle. The higher the eccentricity, the lower, the further away from a circle that is. Okay. Last thing. Hyperbola. Hyperbola, I would say, is one of the most sophisticated conic sections. These are all non-functions, all conic sections. The circle, the parabola opening left and right, the ellipse, and the hyperbola. And I like to start with a graph for any problem. On page 748, problem 14. 9x squared minus 4y squared equals 36. What is the first step? I know I only have 5 minutes left. Yes, I have to divide both sides by 36. So I have 9x squared over 36 minus 4y squared over 36 equals 1. The question here, I lost it. Okay, the vertices, foci, and the asymptotes of the hyperbola, and sketch his graph. Okay. Good, I will have to simplify. So then I have x squared over 4 minus y squared over 9 equals 1. Okay. Now, you notice that this is the reverse situation from before. In the previous, when we looked at this ellipse, a squared was bigger than b squared. So, because a squared is bigger than b squared, the major axis is on the x-axis. Now, in this particular case, we notice that a squared is smaller than b squared because 4 is smaller than 9. So the hyperbola will not be opening on the x-axis, but it will be opening on the y-axis. Okay. Slightly more difficult situation. Okay. So this is my a squared, which is 4. So then a will be 2, go up 2, down 2. And I have b squared, which is 9, so b equals 3. 1, 2, 3. 1, 2, 3. I started with a graph, but that's okay. Once I determine a and b, a is on the x-axis, on the y-axis, and b is on the x-axis, I will create a box. It's not part of the graph. So please do not graph it as a solid box. Then I will draw lines through 3 points. This point, the origin, and this point. The same thing on the other side. These are, and we'll identify them in a minute. I know, only 2 minutes. I'll stop, but we'll finish on Wednesday. So these 2 lines are the slant asymptotes of the hyperbola. And now I'm ready to graph the hyperbola. And the details, as I said on Wednesday. Through this point and approaching the asymptote. Through this point and approaching the asymptote. Through this point and approaching the asymptote, and approaching the asymptote. We'll identify the foci here, and we'll determine the equations of the asymptotes on Wednesday. And this is the graph of the hyperbola. As you notice, all these 4 conic sections are not functions. By the vertical line test, they're not functions. So on Wednesday, I would like to review the important information from chapter 4, and I would like to graph again, finish up this, and graph again one of each, a circle, a hyperbola, an ellipse, and a parabola. And that is it.
So everything we cover up to today will be on